This is a question on continuous random variables probability distribution that was asked in 2021 exam. The random variable x has probability density function which is given by k x to the power of -4 for x greater than or equal to 1. The probability distribution can be for either discrete random variable or continuous random variable. For discrete random variable, you will be given the probability distribution in the tabular form where we are able to list the possible values of x and with the corresponding probability p of x, which is called probability mass function. But for continuous random variable, the function that is used to find the probability is called probability density function. The f of x is the probability density function that is used to find the probability. That is a function that describes the probability of the continuous random variable x. For any probability distribution, the total integral for all possible values of x, the total probability for all possible values of x is equal to 1, and we find the probability for continuous random variables probability distribution using integration. Why is that so? Suppose if this is the probability density function PDF that you are given, which is defined between a and b. The function PDF, which is used to find the probability, is defined between a and b, which means that the total probability of x taking value between a and b will be 1, and the probability is found by integrating the function between a and b, because that is what gives us the area under the curve between a and b. So when you find the probability using probability density function, the probability is calculated by finding the area under the curve, and to find the area under the curve we use integration. And we also have an important property of the probability density function, which is equivalent to saying that the total probability is equal to 1. The total area under the curve between the range of x where the function is defined is 1. Therefore, the integral over the whole range of x where the function is defined of the function will be equal to 1. That is a fact that we are going to use to solve the first problem. So the first question, this function, the probability density function, has got an unknown k. And we need to find the value of k. And how do you find the value of k? We find the value of k using the fact that the total probability is equal to 1. And the total probability is nothing but, in this question, probability that x is greater than or equal to 1 is equal to 1. Why probability of x greater than equal to 1? Because that is where the function is defined. And how do we find the probability that x is greater than or equal to 1? We integrate from 1 to infinity the function f of x with respect to x, and that should be equal to 1. Right? And this is the equation that we're going to use to solve for k. So integral of k times x to the power of -4 dx is the definite integral between 1 to infinity equal to 1. When you integrate x to the power of -4, you get x to the power of -4 plus 1, which is -3, divided by -4 plus 1, which is -3. And we have to use the limit 1 to infinity. This is a definite integral where we evaluate the value of the definite integral by first substituting the upper limit for x and then minus substituting the lower limit for x. But before I do that, I'll rewrite the function as -1 divided by 3 times x cubed between 1 to infinity equal to 1. Now if you substitute the upper limit, that is infinity, for x, you have minus 1 divided by infinity. 1 divided by infinity is a value that is too small, that approaches 0. So take it as 0. And then substitute the lower limit. So minus, when I substitute the lower limit 1 for x, you get minus 1 over 3, 1 cubed. 1 cubed is 1. And that is equal to 1. And this simplifies to k over 3 is equal to 1, therefore k is equal to 3. After we find the value of k, which is 3, we have answered to the first question. The function f of x becomes, it was kx power minus 4, now it is 3x power minus 4 for x greater than or equal to 0. So this is the probability density function now, after you substitute k is equal to 3 into the function. Now the second question is to find the mean expected value of x and the variance VAR of x, mean and variance. Now the formula to find the expected value of x is, for a variable which is continuously distributed, a random variable which is continuous, integral over the whole range. So this is the general formula where I say that we integrate over the whole range over which the density function is defined, x multiplied by the probability density function times dx. This is how we find the mean expected value of x. Here in this problem, the whole range is, sorry, this is 1, right? The whole range is that the function is defined for x greater than or equal to 1. So the whole range is 1 to infinity, x multiplied by the density function, which is 3x to the power of minus 4 dx. So when you find this definite integral, that will be the expected value of x. So before I integrate, I'll take 3 as a constant outside the integral and multiply x and x power minus 4, you get x power minus 3 dx between 1 to infinity. So when you evaluate the value of this definite integral, that is the expected value E of x. So 3 times. When you integrate x power minus 3, you get x to the power of minus 2 divided by minus 2, which is which can be rewritten in the next step as minus 1 divided by 2x squared between 1 to infinity. Now substitute the upper limit, infinity for x. So when you substitute the upper limit infinity for x, 1 divided by infinity, which is 0, minus, now you substitute the lower limit 1 for x, you get minus 1 over 2, which is 3 over 2. So the expected value of x is 3 over 2. Now we are asked to find the variance. Variance of x is given by expected value of x squared minus expected value of x, the whole squared. The expected value of x squared is integral over the whole range, which is 1 to infinity, x squared multiplied by f of x dx. So this is how you find expected value of x squared, minus expected value of x is something that we have already found, which is 3 over 2, the whole squared. So u of x is what we found in the previous question. Now let's evaluate this function by substituting for f of x 3x power minus 4, and then this can be simplified. The function to be integrated can be simplified. X power 2 times x power minus 4 is x power minus 2 dx. Okay, now we'll integrate the function. So it is 3 times x to the power of minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1. And these are the limits of the definite integral. So before I substitute the value of 1 and infinity to x, I'll rewrite the function that we just integrated. X power minus 1 is 1 over x, so it's minus 1 over x between 1 to infinity. Now you substitute the upper limit, you get 0, minus, substitute the lower limit, you get minus 1, right? Minus 1 over 1 is minus 1. So this becomes 3. Right, so what I have calculated here is expected value of x squared, right? I've calculated expected value of x squared from this step onwards. So from here onwards, I've calculated only expected value of x squared. Therefore, variance of x, right, continuing from here, variance of x is expected value of x squared that I just calculated, which is 3 minus 3 over 2, which is 3 over 2 squared, sorry, 3 over 2 the whole squared, which is 3 minus 9 over 4, which is 3 over 4. So the variance is 3 over 4. Okay, the next question. So we have found the expected value of x and the variance of x. The next question is, derive the cumulative distribution function of x. Right, so what is cumulative distribution function? The cumulative distribution function, which is denoted as CDF, the short form of that, the CDF, is the uppercase F of x, which is defined as the cumulative distribution function or the distribution function. It can be just referred to as distribution function, right, or cumulative distribution function. So the cumulative distribution function is defined as probability that the random variable is less than or equal to x. So this is how the cumulative distribution function is defined. Probability that the random variable is less than or equal to a value small x. And this probability can be found by, in general, the general formula is to find probability of x less than or equal to x. We take minus infinity to x times f of x dx, and that is what gives the cumulative distribution function. This negative infinity is the lowest value of x for which the density function is defined. Here, the lowest value of x for which the density function is defined is 1, because we have the function for x greater than or equal to 1. The upper limit should be x of the probability density function, which is 3x to the power of minus 4 dx. So this is equal to 3 times x power minus 3 divided by minus 3 between 1 to x. So when you substitute the upper limit, you get minus, this 3 gets cancelled. So actually we have minus x power minus 3. So when you substitute the upper limit, you get minus x power minus 3 minus, when you substitute the lower limit, which is say 1 for x, you get minus 1. So the function is 1 minus x to the power of minus 3. Right? So this is the cumulative distribution function that we have calculated. This cumulative distribution function that we have calculated is valid only for the range of x for which the function is defined, which is x greater than or equal to 1. Okay, so now if you say that the function is defined only for x greater than or equal to 1, the distribution function is also defined for x greater than or equal to 1. So finally we write the answer. Because it is a function that we find, we have to clearly say the function is valid for what range of x. So the final answer will be written as the distribution function uppercase f of x is equal to 1 minus x power minus 3 for x greater than or equal to 1. And what about the x being less than 1? What happens to the function when x less than 1? The function is not at all defined, right? And when you find the cumulative probability for the value below the lowest limit, it will be 0, right? So this is the distribution function. So this is the answer to the third question, right? And that is the end of this presentation that explains a problem on continuous probability distribution that was asked in 2021.